Let's move on to section 6.4. So we're going to talk about sampling distributions and estimators. This is a relatively short section in your textbook, but the homework is probably going to take you a little bit longer because you will be calculating small sample means and variances. Just stick with your homework and it'll be okay. So we're going to look at the sampling distribution of a statistic. So in other words, we're going to look at the distribution of the values of that statistic when all possible samples of the same size are taken from the same population. And we're going to see that some statistics are better at estimating their population parameter than others. The first thing we're going to do is talk about the sampling distribution of a statistic. So again, we look at all possible samples of the same size from the same population, and we look at that statistics distribution. So we're going to look at sample means or sample proportions. And we're going to look at how that statistic is represented by a probability distribution. Now, the sampling distribution of the mean is a distribution of sample means, with all possible samples of the same size taken from the same population. And we're going to look at pictures of this in just a second. So here is why this is important. When we do this, the sample mean actually targets the value of the population mean. So this is a really good way for us to estimate the population mean without having to get data from every individual in the population. And the other cool thing about this is the distribution tends to be a normal distribution. And because it's a normal distribution, we can use the skills that we learned in the last couple of sections to help us find probabilities. Now, the sampling distribution of the variance again looks at the sample variances with all samples of the same size. Now, this is not something we're going to use very often because it does create a skewed distribution. And so again, the sample variances target the value of the population variance. So we use that distribution to help us make decisions. That sample distribution will help us to make distributions to make decisions about the sample. It does tend to be skewed to the right. Now we'll also look at the sampling distribution of proportions, and that means again all the samples have the same size and are taken from the same population. That distribution tends to be normal. Now, one of the things we need to deal with is we need to distinguish between the population proportion and the sample proportion. Population proportion is designated by a lowercase p. A lot of times I'll use a cursive p. And then the sample proportion is a lowercase p with the caret over the top. So sample proportion has the caret. A plain lowercase p is a population proportion. And again, the sample proportion targets the value of the population proportion, and the distribution tends to be a normal distribution. The means, the variances, and the proportions are unbiased estimators. And what that means is they target the sample mean. So these statistics target the population parameters without any built-in error. And so we are going to be focusing in this course on dealing with sample means and sample proportions. We're not going to deal so much with variances, but they're out there. If you need to do it, you'll be able to. But we're not going to focus on those much. So again, these statistics are better in estimating the population parameter than others. Medians, ranges, and standard deviations are biased estimators. That means they do not target the population parameter. Now, we might use standard deviation because when samples are large, the sample standard deviation does work to estimate the population standard deviation. So again, here's an example that we might do, and we might roll a single die 5 times and find the mean and the variance of the proportion of odd numbers of the results. And what do we know about the behavior of the sample means that are generated by this process? Well, if we would look at the sample means, we're going to get some values. And so the measure of center is 3.49. When we do this for many, 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 you can see that we get our normal distribution. And so notice that we get that normal distribution. So we can use the sample means to help us out. Now, what would happen if we simply rolled a die 5 times and looked at all those sets? Well, the distributions of numbers is going to be a uniform distribution. Now, if we do the same thing with the variances, the population variance is 2.9. Our sample variance is going to be 2.88. Notice that we get a skewed distribution. And then if we do the same thing with proportion, look at the proportion of odd numbers, our population proportion would be 0.5. When we look at our sample proportions, the mean is 0.5, and our distribution again is approximately normal. Now, when we do this, we're talking about sampling with replacement. Why do we do that? Well, the thing is that our calculations will be much easier. So when we have a small sample from a large population, first of all, it doesn't make any difference if we replace or not. The second thing is if we calculate with replacement, then we have independent events, and that makes the math easier to analyze. We're all for easy. But be careful. When we do simple random samples, we can use the techniques that we're talking about here. But when we're talking about those poor sampling techniques, there's nothing we can do to fix it. So again, bad sampling techniques gives us bad data, which gives us bad conclusions. So in this section, we've talked about the sampling distribution of a statistic in general, of a mean, variance, and proportion specifically. We've talked about estimators. We talked about the mean, the variance, and the proportion are unbiased estimators, meaning that they will not estimate with error. And we talked about the median and the standard deviation and the range are biased estimators. There will be error in those estimates.